listening to The Weather Junkies.
Oh boy. Large wedge tornado coming up into Tuscaloosa. A winter storm warning is in effect for our area.
Snow, we can expect at least another 2 to 4 inches overnight. Then that snow is covered.
The National Weather Service in Huntsville has issued a tornado warning for northwestern Massachusetts.
14 to 22 inches of snow!
Good Thursday evening. I'm Tyler Jankowski, joining the show from Connecticut, as always, alongside my counterpart, Dakota Smith, who is not in Colorado. He is near New York City, right, Dakota?
Yeah. Where in the world is Dakota Smith right now? I'm in Hoboken, New Jersey, out here visiting for my spring break, just right across the river from New York City, spending some time in New York City, and even going to get it into Pennsylvania this weekend. So the weather around here has been pretty similar to yours. Really nice and kind of rainy.
Yeah, we obviously have had a relatively snowless winter, and we've had an 80-degree day. We hit 81 degrees, set a record, not only for the day, but also for the earliest 80-degree reading in over 100 years of record keeping. And you would think that means spring is around the corner or already here. Yet the threat for a major snowstorm this weekend is growing, and it's quite high. I mean, many areas in New England are probably going to get walloped with snow and wind and coastal flooding. I mean, it's so ironic. The first day of spring is Sunday, and the snow will likely be moving into areas of the Northeast, especially New England, Sunday afternoon. So some areas could see a foot of snow, still 3 days out. Don't know exactly where that is, but the European model, the recently upgraded European model, has really locked into a solution. In fact, the storm may actually come far enough west that there's mix issues as you head out east towards Cape Cod, the islands, and eastern Long Island. So I don't know. I mean, this would be probably a fitting end to an already crazy season if some places see 12 or 15 inches of snow by the time Monday morning rolls around.
So I have a flight going out of Newark, New Jersey, 5 o'clock on Monday. Will I be delayed?
5 a.m. Monday or 5 p.m.?
PM.
5 p.m. I am not familiar with, I should say intimately familiar with how airlines work and how long delays last, but I don't think so. I don't think it'll be snowing then. I don't know how long the delays will last once they begin, but I think if you said 5 a.m., you'd be screwed out of luck. You wouldn't be leaving.
When I came back east in January, my flight was out at...
Nonetheless.
What's that?
For the storm you came.
Oh, yeah. I did come for the storm, and my flight got delayed. It was on Monday morning, and snow had ended by, 8 p.m. Saturday, given that was, an historic storm. So this is not nearly in that magnitude for this area. And, yeah, I'm looking at the NAM right now. I know that's not the best, and I'm just looking at one model. No, I'm sorry. I'm looking at the GFS, and looks like I'll be okay.
Yeah, right. The GFS has been a little bit confused. Still has a wandering eye on the Europeans test.
Are they that different timing-wise, do you know?
The GFS is more so during the day Sunday, and it's lighter in intensity, which would be a problem for the time of year. We're talking March 20th. So if, in fact, the GFS solution came out to be correct, we'd have trouble accumulating snow on the roadways with light snow, temperatures above freezing, the high sun angle, midday. I mean, it just would not be a combination that would result in a lot of snow.
Right.
The European is later. The European is Sunday night into Monday morning. I should say Sunday afternoon into Sunday night, ending, say, around daybreak Monday, with the bulk of the snow being overnight. And it's much more intense. I mean, the Euro is just a textbook solution. Again, it is trending a little bit west, especially with the ensemble clustering to the west of where it currently stands. So that's why mixing is probably going to be a concern the farther east you head. But, in the Hartford area, we've seen roughly 17 inches of snow on the season, for the season. And this storm has the potential to drop at least a foot in some areas. So it's very possible that some spots in southern New England, the Albany area, see a storm that rivals the total snowfall for the season thus far, which
Wow.
is hard to comprehend. But again, it'd probably be a fitting way to end a season that's been crazy to begin with.
Yeah, so it's kind of funny, a little bit of a coincidence. They're actually getting a nice snowstorm across the Front Range in Colorado right now. They're getting, at least in Fort Collins, they're getting around 3 to 6, 4 to 8 inches. It's kind of weird, actually. Usually, you don't get storms happening at the same time in the plains versus the Northeast. So, kind of an active pattern wind right now for the United States.
Yeah, and the pattern for this weekend storm is a favorable pattern for a storm along the East Coast. It remains to be seen exactly where the storm track lies. I do think it will be a little bit farther west, but the timing of the storm on a Sunday, the first day of spring into Sunday night, it's mostly overnight. So I think a lot of schools in the area will be closed on Monday morning, and along with many businesses. But from my perspective, I'm out of state this weekend, coincidentally visiting you. So it'll be kind of fun to enjoy the storm out in the storm for once, and probably driving in at least some snow on Sunday evening. So that'll be very fun to be out in the storm as opposed to working in it, as we so often do as meteorologists.
Yeah, I agree. Although I don't know what it's like to work a storm, but it will be it will be a lot of
Soon
fun
enough.
to be out in the snow. But right now, let's get into our tweets for this week, and kind of following along the lines of what we've already been discussing. The first tweet comes from Harrison's Sienkiewicz, and it says popcorn across the sky with gravity waves evident in some cumulus clusters / cumulonimbus as they hit the stable layer. So there was quite a bit of shower activity across parts of eastern Pennsylvania and even parts of New York and New Jersey. And it's a very, very pretty satellite imagery. Tyler, did you cover any of this today?
Yeah, actually, last night we had some thunderstorms. There was one that came through 8, 9 o'clock. Then there was another one that actually woke me up around 1 or 2 a.m. A couple of big claps of thunder, but not severe. Today there was some thunder, not where I was, but in the northern part of the state. And again, tomorrow there's the chance for some thunder. So quite a lot of thunder for the time of year, particularly in middle March.
Yeah.
I wouldn't say that's typical for a place this far north. But we don't have any snow. We don't have any snow, and it's been pretty warm. And when you think of the storm potential on Sunday, it makes it even crazier sounding, because we're having thunderstorms. We did have severe weather back in February. Now we might be dealing with a foot of snow, and right after the storm, looks like we hit 60 at least on Thursday. So if we do get a lot of snow, it's probably not going to stick around that long.
Yeah, I don't. To be honest, I don't like storms like that. I like to kind of enjoy the snow for a day or two.
Yeah, it's
or long.
tough this late in the season.
Yeah. So on to our next tweet here. This actually came up last week. It's from Marissa up in State College, and she works for Penn State Meteorology Department. And her tweet says, State College's least snowy season was in 1979 to 1980 with 17.9 inches. This season, we've only measured 16.4. We better not get more than 1.5 inches on Sunday. So it's kind of like there's a split here. Some people are pulling for the record because you love to see records as a weather enthusiast, but some people want the snow. They'd rather be able to go through a snow event that is impactful and kind of enjoy that. I'm on the record side. Tyler, what side are you on?
I'm on the record side, whichever side of the spectrum it is. If it's a lot of snow, a little snow, record warmth, record cold, I like to live through history. Obviously, every part of weather is history, but on the extreme ends, I like it. So, it may get tiring after a while, but if we're 1/10 of a degree away from a record, I'm all for whatever we need to make that record go into the books. This State College record is particularly interesting because the records there go back quite a ways.
Yeah.
Looks like Marissa responded there 1893. So that's longer than a lot of climate sites across the country. Hartford goes back to 1905, for example. So we are in the top 10 least snowiest here in the Hartford area, which goes back to, again, roughly 1905. So the least snowiest season in State College by more than an inch. She says you better not get more than an inch and a half. I think that might be tough, actually. If you look at the track this storm's going to take this weekend, especially with some of the clustering on the European model, taking the storm over Long Island, Block Island, Eastern Connecticut. I mean, State College can end up with a convenient 2 inches or 6 inches.
Wouldn't that 2 inches would just be terrible? It's like,
Would be terrible. The snow, the person measuring the snow better like breathe on it before they measure it.
We don't want a snowfall gate up there. That wouldn't be good. Yeah, so hopefully we don't get a lot of snow. We're going to be traveling up there, so I kind of want to avoid snowy roads.
Yeah, probably have some on the way back. I wouldn't mind it. Our next tweet, I'll take, then Dakota will take the next one after that, is it's actually a tweet from me. I wanted to find a tweet from someone else, but I had some difficulty finding one. But in Ohio, coincidentally on the day that everyone voted out in Ohio on Tuesday, there were tornadoes. I believe there was more than one tornado, and there were, why am I saying I believe? There were, because I'm talking about TDS signatures, tornado debris signatures. And I personally saw 2 debris signatures in the Dayton, Ohio area on Tuesday. One of the debris signatures was several miles wide. It was impressive, especially when you consider the area that the tornado was occurring in, farmland. So the debris in the air was probably pieces of a barn or a house or something that it picked up, because in farmland there's not a whole lot of trees. There's not a lot of structures except for the barns and the houses and maybe a shed. So some very impressive severe weather in the Dayton, Ohio area this past Tuesday. And that's a topic that we're going to address in a future episode. That is the tornado debris signature, such an important part of dual pole radar that has come along here in the last couple of years. Essentially, you can confirm a tornado with a radar scan, and you don't need anyone on the ground. So it's groundbreaking technology. You don't always get a tornado debris signature with a tornado, but it's something that we really want to delve into in a future episode, so that our listeners, perhaps some meteorologists listening, can brush up on the latest research as it relates to a tornado debris signature. And for those that are just listening in to get somewhat of a behind-the-scenes look at meteorology, I think it'll be fascinating. Of all the things in meteorology, I would say the TDS is up there on my list in terms of things I'm interested in. And I always say the reason is because so few things are 100% certain in meteorology. And when you have a clearly defined TDS where there's no doubt, that is 100% a tornado. I mean, there's no question. So that's why I selected that tweet, and we'll talk about it more in the future.
Yeah, hopefully we can get on a radar meteorologist to talk about that, because I would like to hear an expert's kind of opinion on the groundbreaking data that we get now from dual pole radar technology.
Perhaps the status of the aging radar network.
So the next tweet is not nearly as sciencey or in-depth as yours, but it comes from Ed Valley, and I thought it was a very comical tweet. He said, "Ready for winter to end. 6 months of hundreds of Type A personalities going back and forth is draining." You know, it's kind of funny. There's a lot of, when it comes to snowfall, there's a lot of banter back and forth, usually kind of negative and angry, and it doesn't happen nearly as much during any other time of the year. Snowfall is kind of like this in your backyard thing that people, they really want. They want to have the highest snowfall measurement, and so that makes them want to, like certain forecasts, dislike other forecasts, and it's this back and forth. Winter's over, winter's not over, and it's a funny tweet, but it's a good point. And I just I've learned to kind of ignore a lot of that back and forth and stick to looking at the data and looking at models and looking at good forecasts. Um, it brings up a good point, but it's also pretty funny.
Yeah, it is tiring, especially when you have such a low hit ratio this season. We really haven't gotten hit a lot in the Northeast, in New England, with storms, but we've had a decent number of threats. That brings us to our next tweet, which surrounds the European upgrade. The vaunted European model was upgraded a week and a couple of days ago to 9 kilometers on average. And that essentially brings it into the range of mesoscale models. Now, it's not a mesoscale model, it's a global model, but the resolution is on par with models like the NAM, the RPM, the RGEM, the regional Canadian model. It's impressive, but it's not just the resolution that goes into a good model. It's the equations, the way you put the equations together, the data that you use and how you ingest it. And this upgrade called 41R2, I believe R probably maybe stands for revision, not sure. But the upgraded European not only increases the resolution, but it adds an accumulated freezing rain product. It is supposed to have more realistic depictions of tropical cyclones with some better rain band modeling. And it also changes some of the way the grid works. So a whole bunch of different changes with the European model. And so this weekend storm is probably the last one of the season. It's also the first big test for the new European model. So this is its chance to go out of, say, the active season on a winning note. And it wouldn't surprise me if it does, because it's been pretty consistent with the last few runs. So it looks like the GFS gets its next upgrade in early May. So the model wars continue.
I would like to see the research behind how these upgrades impact forecast accuracy. I know it's out there, but I haven't done much of my own research into some of the papers that they put out. But I'm curious to see how one upgrade or a cluster of upgrades affect the model accuracy.
Yeah, apparently the new European has better temperature, wind speed, and maybe dew point forecasts at the surface. The European Center for Medium Range Forecasting does a phenomenal job laying out their ideas about the model. They do not shy away from flaunting its skill. If you Google ECMWF upgrade or model limitations, you should find a web page that's put out by the European Center that lists, say, 30, 40 problems and known issues and things that they've fixed recently in the model. It is mind-blowing, the amount of detail that they go into. For example, they know that there's an issue with the sea surface temperature modeling in the New York vicinity. I mean, we're talking global model, and one of the points is an issue with the sea surface temperature near New York. It just goes to show you the detail-oriented approach that they take, and even though you have to pay for the data, they are very public about their problems and their upgrades that they are doing to the model. So a very interesting webpage. If you do a quick Google search, you can find some of that information.
Now that I'm thinking about it, they probably do their own internal kind of research before they upgrade it, and they probably have a good idea of how it's going to improve.
Yeah, I believe this upgrade reduces upper air errors by 2 to 3%. It's hard to visualize that, but it's in the right direction.
That's important. Upper air, as we know, upper air forecasts are what drives the surface. So, so our next tweet comes from John Morales. He's a broadcast meteorologist on NBC Miami. And this tweet says, led by ABC 2015, combined climate coverage decreased 5% from 2014 despite landmark actions. And, 5% isn't that big of a decrease in terms of coverage. But it's interesting. We had this summit in Paris, this huge historic climate summit in Paris, and there was less coverage of climate change compared to 2014 and 2015. I don't know. It's not a good thing, right? Because it's important to cover one of the biggest kind of issues that our Earth is facing. But a lot of people were very, very upset about this and kind of worried about it. But I don't know. To me, 5% isn't a huge decrease. It's probably just a minor fluctuation and not an overall trend, I would say.
Yeah, I saw some tweets about that, and one of the things that I heard was Fox News Sunday, you know, a program that you would think would have a lot of deniers on, actually had, I believe, the least amount of climate deniers on.
Oh yeah, I saw that
show. So it was very interesting.
Our good friend Ryan Breton tweeted that out.
Yes, he did.
He tweeted Fox News Sunday had more segments that didn't include denial than any other Sunday show. How about that? So, like, that's good, right? I like that. less climate denial, the better coverage.
The reason that the actual overall coverage went down is still a little bit puzzling, but
Yeah.
maybe was that for the year 2015?
Yeah, that was comparing 2014 to 2015.
Maybe it had to do with the election.
That's certainly possible. Yeah,
Take that more time.
all those Trump headlines.
Yes. One thing, moving on, the other thought that I had today was I saw someone post in a Facebook group that many of us broadcasters are in, and it was regarding sirens, tornado sirens as we call them. But the sirens, this person said, were going off for a severe situation that didn't involve a tornado. It was either a flash flood or a severe thunderstorm. I believe it was a flash flood. So the debate that was going on was, should tornado sirens be used in other severe situations when people seem to know that noise being related to a tornado? Is it confusing? And this is a whole nother debate for a much longer show about sirens in general. But that was interesting to hear that the sirens were used for something else.
Yeah, it certainly is. And we actually got a message from a fan concerning the warnings on cell phones and warnings via sirens. And he suggested a few, some literature to read, specifically an issue of WeatherWise that discussed a lot of the warning siren issues, and then there was another one about how the warnings are issued via the cell phone towers. So I didn't actually get to respond yet, so sorry about that. But I did read it, and Tyler and I, and we had on Becky last week. None of us are experts in that field, and he suggested having an expert on, because it's certainly an issue that we could dive into. So yeah, thanks for that email, by the way. Jay sent us a message, so thank you, Jay, for that.
All right, now on to our main topic for the evening, forecasting tornado activity weeks in advance. We have a special guest joining the Weather Junkies tonight from the Chicago area, I believe, Illinois. Victor Gensini. He is a professor at the College of DuPage. You may be familiar with NEGS Lab if you look at model information, and that originates from the College of DuPage. And would I be correct in saying you have a large role in that, Victor?
Yeah, that's correct, Tyler. So we can definitely get into that in the show, but I play a critical role in helping develop and maintain the site, the weather.cod.edu website.
So let's learn a little bit about you and as it relates to meteorology and where you are today. Where did you start out your career, and what are you doing today as your primary focus?
Sure. So first of all, thank you to Tyler and Dakota for having me on. It's a pleasure to be here with you guys. I've sort of just in the last couple of weeks learned more about Weather Junkies and listened to some of your podcasts, some really good stuff. And so I just sort of quickly here walk through my background. I grew up in north central Illinois in Putnam County. It's the smallest county in the state of Illinois. very, very small farming community. The entire county didn't even have a stoplight. So it kind of gives you a sense of where I grew up. Our high school didn't even have a football team, so my graduating class was on the order of like 70 to 80 people, so fairly small. And in 2004, when I was sort of getting ready to exit high school, the Granville, Utica tornado occurred in Putnam County, and really clipped the elementary school, or hit the elementary school, clipped the high school, went on to do F3 damage in the town of Utica, Illinois, where the Milestone Tap, which was a sort of a safe haven for people to go and take shelter during storms, the Milestone Tap collapsed, and it killed 8 folks inside of it. It was sort of a tragedy at the time, and I really didn't know much. I had an idea about weather. I had an interest in weather, but it was really that event and seeing the damage of that event firsthand that really sort of drew me in to a career in meteorology. And so from there, I left. I kind of was on a path for engineering in my early days in college and had switched over to meteorology. I transferred to Northern Illinois University in DeKalb. I finished off my bachelor's there and also my master's, where I had a wonderful advisor who I still am really good friends with today. And he kind of pushed me to go on for the doctorate, the PhD, where I transferred to the University of Georgia to finish off my PhD, and now I'm back in Illinois. So it's kind of made full circle here, and happy to be back home in the Midwest. I like Illinois. I like the distinct 4 seasons and the severe weather cycle that we have here. And yeah, so that's just kind of a brief overview. I've done some internships here and there along the way across the country, but for the most part, I'm glad to be back in the Midwest.
So the topic tonight is some of your recent research that has made the news, and that is forecasting tornadic activity weeks in advance. So kind of take us into this by your motivation and how you got the idea for this, and maybe it starts with you living in the Midwest and wanting some more notice for tornadoes.
Yeah, so the last week has been really a whirlwind of not only media but just questions about the research. And last Saturday morning, I'm sitting here having coffee and I'm watching my name go across the ticker, major news outlets, and it was at the time it was extremely surreal that the research was getting that much notice. But at the same time, I think the headlines were a little bit blown out of proportion, right? I'm getting questions from people like, you can predict tornadoes, when they're going to happen 3 weeks in advance, or is it going to hit my house? I'm getting all these people calling and asking, what am I going to get hit by a tornado in the next 2 weeks? And I think that just goes to maybe a little bit of the sensationalism in the media around the story itself. But really, if you dive into the news article, the article itself is actually fairly accurate in terms of what we're trying to do. The headlines, I think, were a little bit blown out of proportion. So,
Well, it's just like there's never any warning.
Yeah, right. And and we can get into this. This type of research is not going to change the way we do watches and warnings in the United States by any means. We're merely trying to forecast activity levels for tornadoes relative to climatology in weeks 2 and 3. So, we're not going to tell you tornado in Kansas in 2 weeks from now. What we are saying is that the synoptic weather patterns are either going to be favorable, unfavorable, or sort of neutral at this week 2 to week 3 time frame, which is already challenging because we're dealing with a phenomenon, tornadoes that are relatively short-lived in time and produce a fairly small swath of damage. So, yeah, I think the motivation for the research really stemmed from, my passion and love for severe weather. And a lot of this research, the beginning of this research, was done with a colleague, Al Marinero, at Northern Illinois. When I was teaching at Northern, a night class, I had gotten to sit down and have some pretty lengthy discussions with Al about the global wind oscillation and angular momentum, and how we both speculated that it played a role in tornado activity. And it wasn't really until we started doing the research that we uncovered this strong link.
So you mentioned something that I was thinking the same thing. All the headlines were super misleading, and I read a lot of headlines like forecast tornadoes 2 to 3 weeks in advance. And to me, I was just like, oh my gosh, first of all, I was like, wow, if that's true, then wow, that's awesome. But I have a meteorology degree, so I was like, there's no way that's possible.
Yeah, right. And anybody with a meteorology degree, that headline should never have passed the smell test, right?
Yeah.
There's something about, and I will say we are forecasting tornadoes at week 2 and 3. So I don't want to lead people to believe that we're not doing that, because we are. It's just that we're not predicting we're not going to predict that a tornado is going to hit your town or your home in weeks 2 and 3. We're merely giving activity level forecasts relative to climatology, and these forecasts are available to the public, by the way.
Yeah. So what is your forecast going to mean to, I don't know, maybe the SPC or someone who's looking at an SPC forecast? How do they take this stuff into consideration?
So our current interaction with the Storm Prediction Center has been somewhat limited. I consider Greg Carvin a really close colleague who is at the Storm Prediction Center, and I know many of the forecasters on a personal level from the SPC. And the short answer is Greg is departing the Storm Prediction Center and heading to the Weather Prediction Center in Camp Springs. So we may lose a little bit of momentum on the short term in terms of these seasonal type of forecasts. To be honest with you, you might see them in an operational sense through the Climate Prediction Center first. So if you're familiar with the Climate Prediction Center, 14 to 30 day temperature and precipitation outlooks, we think we have enough momentum to go in that direction. So, giving it A average, AA above average, or BA below average tornado activity level forecasts through a very similar mechanism like the Climate Prediction Center does. But this is going to be, if and when that ever does happen, this is going to be, a multi-institutional effort between College of DuPage, my co-author Al, David Gold and Ed Berry in the private sector have had a lot of discussions with me about this. Brad Barrett at the U.S. Naval Academy, John Allen at IRI Columbia. So this is going to be, by the time this is all said and done, there's going to be a lot of people with, the iron in the fire, if you will. They're going to be helping make these forecasts. And I think that's where we're going. We're going to continue to try to narrow down, maybe a 3 or 4 state area in these forecasts. But right now, it's just activity level east of the Rockies. So it's a pretty broad brush forecast.
Now, you are using mid-level information, so 500 millibars typically around 18,000 feet. As a forecaster, we always look at that level. Can you give us maybe one thing that you look at in particular to figure out when tornado activity will be enhanced, other than just looking for a trough or a low-pressure system?
Sure. So the idea of our research, which, by the way, this isn't something that we just kind of magically started and pulled out. This research is published in Monthly Weather Review, the February 2016 issue. If your readers or your listeners want to check it out, it's based on the global wind oscillation, which is angular momentum, and so it's not just one level, 500 millibars or 250 millibars. Which we would consider jet stream level. This is actually every vertical level inside of the reanalysis or the model, and we're trying to capture the zonal east-west component of the wind. So it's a vertical integral, and it's also a zonally sort of summed mean. We're basically trying to capture how much westerly flow there is on the globe. That's the idea of the angular momentum measurement. So it really is a total vertical structure of the atmosphere, and it's not just at one latitude, it's over the entire Earth.
So you mentioned that one of the ways we may get it out initially is the Climate Prediction Center. That's pretty interesting, because I do find those outlooks very valuable, the temperature and the precipitation, particularly days 8 to 14. So to actually see this make it into the operational world would be quite exciting, especially alongside those products that so many people come to respect and use in their forecasting process. What would you say is probably one of the more surprising things that you've discovered in doing this research as it relates to tornadoes?
That would probably be the fact that this global scale, and it really is a global scale index, predicts, or at least explains, a lot of the variance of these very small scale, storm scale phenomena, right? I mean, we're talking about a metric that is calculated based on all points of the globe. And to see this sort of a strong relationship at the global level, the planetary level, if you will, to this very, mesoscale, even storm scale phenomena was actually rather striking. And it really, if you kind of understand angular momentum, what I like about angular momentum is that it physically makes sense. When we have low angular momentum, we see lots of ridges and troughs across the hemisphere, and we can, sort of anticipate when the Pacific jet is going to collapse, if you will. It's a very strong east-west state, and we can sort of, as westerly momentum is added to the atmosphere, eventually, since angular momentum is conserved, we'll sort of watch these patterns collapse into a much more roller coaster, ridge trough scenario. And it's that ridge trough scenario, when that ridge transitions and collapses into a trough in the west. Those big troughs that come out of the western United States this time of the year, and as we go towards May and June, those are the ones that set up the southerly flow at the surface, and sort of the favorable environment for severe storms. So it's kind of like the planetary scale, modulating the synoptic scale, which modulates the mesoscale, which then sort of transfers or sort of chisels down, if you will, to the storm scale.
So you broke up the angular momentum and its time derivative into different phases.
That's right.
And those phases were very indicative of the tornadic activity. And to me, it seemed like this kind of this kind of predictor does really well with the big outbreaks, and when because it seemed like it did really well with EF4 and EF5 tornadoes. It did well with the lower end tornadoes, but it seemed like it did a little bit better. I was wondering if you could, I don't know, maybe elaborate on that, and if that's actually the case.
Sure. So anytime you're dealing with the tornado data set, we see big problems with EF0s. In fact, anybody that's doing research with tornadoes, we kind of joke the number one rule is just to toss out EF0s. You get way too many of these weak tornado reports, from storm chasers or spotters or emergency managers or police officers or whoever it is, that it just really clouds the data set. And so if you kind of just filter those out and look at F1 and greater, there's a much stronger signal, as you would expect to be the case. And when you're thinking about these big troughs coming in with strong speed maxes, and those are the kind of situations where your outbreak days are typically the days when you're going to get significant tornadoes, so F2 and greater. And you start getting to the violent end of the spectrum. Those are typically on very synoptically evident weather setups. And so it's really no surprise to me, or probably any other severe storms researcher, that we see a stronger signal when looking at significant tornadoes and these big outbreak days.
So can this type of method be applied to other areas of the world, or is it pretty specific to the United States and the central, specifically east of the Rockies, that Central Plain area?
The way we set up the study, I mean, this is really only going to be useful for the Central Plains, and that's where we saw our strongest signal, was really the Central and Eastern Plains. That doesn't mean that you couldn't apply angular momentum to other areas of the world. It's just that we really didn't look at that in this study.
Yeah.
One thing that you probably could do is take our results and, or at least the idea of our methodology, and apply it to things like big winter storms, or flooding events or blocking events. You could, I think there's a lot more to uncover about GWO and this idea of angular momentum than just tornadoes. We focus on the tornado problem because we're for a lack of a better term, convective junkies. So, I think there's other maybe phenomena that could be explored. It's just that we really started with tornadoes. As for other parts of the world, no, you can't really apply this idea of an 8-1-2 phase transition for severe weather in other parts of the world. But there may be a phase relationship in other parts of the world that we just haven't investigated yet.
Can you give us an idea of the timeline of this research? How long have you been working on this, and where do we go next?
Great question. I would say now it's been probably a year and a half, almost 2 years in the works of this GWO research. And wow, we are just scratching the surface. We have hail days to do. We have severe thunderstorm convective wind gusts. I just had a conference call today with some colleagues talking about sort of next steps for an environmental approach and a predictive model. And you just go type GWO into Google. You're not going to get that many hits, and you're not going to get that many monitoring products. Certainly not anything like you would find if you typed in El Nino or Madden-Julian oscillation. And so I think we have a long way to go in these monitoring products, prediction products that are really going to get us to where we need to be if we want to start really addressing this 2-week to 3-week forecasting issue. And so, right now, this idea of ERTAF, these forecasts, primarily based on current analysis of GWO, and then maybe a statistical dynamical blend of the European weeklies and the CFS chiclets and the GEFS to really make these predictions based on what we're seeing in the angular momentum. So we really do have a long road ahead of us in terms of research.
So I'm curious. I think we kind of went to this note, but we didn't kind of get into the details of it. What do you think? What do you think this could mean for a forecaster? Say a forecaster that does severe predictions out to I guess they do 7 days at the SPC. Do you think I know you said it's more going to be probably if it's implemented it'll be more CPC, but I feel like this could be useful for them because it's the paper is written so well, and it is a clear indication. When you have these phases, it's more likely. When you have the other phases, it's less likely. Do you think they'll take this into consideration at some point if you guys start to prove continually that it's a good predictor?
I think unless the SPC, their current assignment changes, they probably won't do much with this. And the reason for that is they're tasked right now with only doing day 1 through 8 forecasts, which primarily involves dynamical models. So they're using, for instance, the operational GFS, or the GFS ensemble, or the European ensemble. Until they begin, dipping their toe in the water of an outlook beyond sort of this threshold or this cutoff of numerical weather prediction models, I don't know how much they would actually use this. It might be a situation on a day 8 outlook. We're talking about one of these phase transitions and how favorable it's going to be in this type of regime. It's something they could probably use to maybe verify the dynamic models, but this is going to be much more useful on the 2-week to 3-week, what we call subseasonal forecasting. So whether or not that's an insurance company that's interested in potential losses next month, or the CPC trying to get an idea of activity level forecasts, or emergency managers that are interested in trying to move assets or educate the public based on an enhancement or maybe below average risk for severe weather. So I'm not sure how the operational utility at the SPC, given what they currently are tasked with doing, until I do believe at some point there's going to be this triangulation between academics, maybe the privates, or maybe it's more of a square. The academics, the private sector, the CPC, and the SPC, and as soon as that you know, as soon as really somebody in the government takes that charge of forecasting these events, you know, I just don't know how much interaction there will be or operational utility. We really need somebody in CPC to help push this forward. And we had some momentum with Scott Weaver, Dr. Scott Weaver, but he ended up leaving for the private sector. So we're kind of back to square one in terms of pushing this, you know, operational utility forward.
If you didn't get a chance to read the paper, it's a great paper. I think I ended up like 3 or 4 papers deep after that, so it is a little bit of a rabbit hole. But if you want to read it, we'll put it in our description, link to the PDF. And we asked this one question to all of our guests to kind of wrap up, and it's kind of focused, or sorry, it's to our like younger viewers that are listening. What's been your most important skill or skills throughout your career?
Ooh, interesting question. To me, the turning point in my career was in 2007. I applied for an internship, an REU internship, which stands for Research Experience for Undergrads, and it was the OU, the CAPS OU REU at the National Weather Center in Norman. It was actually the first year. Really, that was the year the Weather Service, the National Weather Center in Norman was finished, and I went out there for a summer, and you know, I learned more in that summer studying under Harold Brooks at the Severe Storms Lab than I really learned at any other point in my career. So my advice would just be to younger students, and there's sort of a skill set I would recommend, but my advice to younger students would be, you know, become really as involved as you can. Show as much interest as you can, act like you care, be passionate about what you do, no matter what you do. Do it to the best of your ability. And you know, if that means sacrificing a little bit now of social life to really focus in on learning the research, it's the only time in your life as a student where you can devote, you know, 100% of your time to learning. And when you get into your professional career, there's going to be classes that you're going to have to teach, you're going to have to go give that on-air broadcast, you're going to have to put out that forecast, and you're not going to have time to devote 100% of your life to really learning. And so I would say take advantage of being a student and just learn as much as you possibly can and surround yourself with people that are smarter than you. If you are comfortable with what you're doing, something is wrong, and you need to sort of push into a realm or a community that surrounds you that you feel uncomfortable with, of people that you look up to, and that's where you really start to learn. And that happened to me in 2007. I was surrounded by people that were way smarter than me, and I sort of picked up on the best traits and the best characteristics of all of them. And I'd like to think that, you know, the way I teach is a reflection of the great mentors that I've had in my past. And so, you know, that's what I would just say for a philosophy. In terms of skills, I can honestly tell you there's one skill that's more important to me than anything else as a student, and it was really 2 skills. The first skill is computer programming. You really have to be comfortable with computers. If you're not comfortable with computers, I don't think you're really going to be an atmospheric scientist that's making a difference in the next 20 to 30 years. You have to be comfortable with computers. The second thing is really strong communication skills and writing. You got to be able to compose an email. You have to be able to get across your thoughts in a way that, you know, is scholarly, professional, and that, you know, you can really start to address these sort of questions. And, you know, writing papers is part of that, but it's more than that. It's talking to people and explaining your research to people. I think that's really the most important thing.
Great advice. Nice long answer there, and we hope.
Yeah, sorry for the length of the answer. It's just that, you know,
that's the kind
as a teacher, I can be pretty long-winded.
No, I like it. There are a lot of. I like the passion. I like the computer science. To me, those are 2 things that you got to have in this field to really thrive.
Yeah, and I think that really shows through on our website for your listeners that do look at models. You know, I would certainly invite them to take a look at weather.cod.edu. It's really a labor of love of, you know, me and another full-time professor and 2 other part-time people that are really devoting, a lot of our time in some cases. And I was working on the site for about 3 hours today. No pay, just kind of a labor of love. It's something that we like to do for the community, and but the only reason we can engage in that is because we like to program and we like to display information and use computers to our advantage.
Thanks for all the work you do there, by the way. I think that page has become a staple in viewing weather data. I'm taking a mesoscale class right now, and we go to that page every class. So yeah,
Great.
Thanks a lot for the work there.
Appreciate it. We always love feedback as well.
All right. Well, thank you for coming on the show. It was a great discussion, and we certainly hope to be in touch in the future, perhaps have a follow-up episode. But our next episode will be next Thursday, and we will do that live Thursday evening. For this show, for Dakota, Victor, and myself, thank you for listening. And we will post a link to the research in the YouTube video, and we hope to have you back next week.